Thank you, and we're really excited to be here. And what we're going to talk about is our use cases for our companies, what worked, what didn't work. And before starting to talk about that, I wanted to say that scaling AI in the business, I think is kind of a multifaceted effort. It has elements that have to do with the cultural changes that we want to have in the organization, as well as internal training. We have to make sure that other people are kind of aligned, they understand the concepts, they understand the potential, as well as the availability of infrastructure to make all of that possible. So on this talk, we're going to focus mostly on the third part, which is the infrastructure part. But don't forget the other two. I think they might be equally important to the success in scaling AI within the org. So I'll start by talking at Lyft. Lyft is really a machine learning company. It's hard to find a problem at Lyft that is not machine learning based. We have internally this separation between the core product division and the self-driving division. And on the core product, as you can see, we have a lot of problems over there that use machine learning. How do we price rides? How do we decide which driver to call for which ride? How do we forecast what the demand and supply would be in some future timeframes, et cetera, et cetera. Also on the self-driving unit, how do we understand whether an object that the car is seeing is a child or another car? How do we plan ahead? How do we match the route to some preconceived notions that we had about what is supposed to be there? So what's common to all of these is that there are people working on hard problems, and while we might think that most of the work is done kind of on the algorithmic side, the reality is really like this. So there's a lot of non-modeling work involved when we build these big solutions. Oftentimes, it takes much more time to work on these non-modeling tasks than on the modeling tasks. And in here, I'm talking about things like, how do I get the features? How do I clean them up? What environment am I using to develop on and to do the training phase and the inferencing phase on? How do I monitor? How do I log? All of these things, we looked at all of these problems, and really the motivation at Lyft to building a platform came from the realization that a lot of people are kind of trying to reinvent the wheel. A lot of people are facing the same problems. We need to consolidate these efforts to build something in a more unified way to allow ourselves as a company to scale better. And the model that we had internally, still have to some degree, is we have this two-in-a-box setup where in a product team, the way we work on solving problems comprises of a person on the left, the data scientist. They're working on creating prototyping, trying to model the problem, trying to get the features to work, et cetera. And the software engineer that handles with productionizing of this setup. And sometimes there's the throw over the wall concept between the two. So the data scientist tries to build something. It works maybe on a notebook, but then there is a bit of a separation between what this person is doing and what the software engineer is doing, and that creates a lot of waste. And it also can take the software engineer a lot of time to understand what the context was, as well as a lot of waste in building the solutions. So we try to kind of map the different steps in this entire process. What do we need to solve for? And we separated it into two buckets, the prototyping phase and the move to production phase. And in the prototyping phase, as you can imagine, right, I'm getting the inputs, I'm cleaning them up, I'm setting some kind of an environment, I'm trying different algorithms in the environment, maybe I'll do some kind of small-scale tuning. And then after I'm happy with the results, the move to production would involve things like expressing all of the computations that take place in a graph that would consistently execute over the inputs, maybe tuning on a larger scale, setting up automatic retraining so the model wouldn't be stale, and then linking all the features in the models together to push to production and eventually work on monitoring and alerting if something goes wrong. These are all components that we've built into our machine learning platform. And what we wanted to do is to standardize a lot of these things so that people would not repeat the process that I described in the last slide. And some considerations on how we designed that. So we made some conscious choices in here, and I'm listing some of them in here. We made the system to be container-based. Containers are kind of nimble, fast, and flexible components in which we can put code and move this code between multiple compute environments. That really helps us move from the prototyping phase to training and to production. We wanted it to be notebook-centric, meaning that once the data scientist builds something on their notebook, it's very easily movable to the production environment. And we wanted to standardize the models and the features. So we have repositories of them, of both of them, and we wanted to make them discoverable such that if I'm in one part of the company, I could take advantage of work that has been done on a different part of the company very, very easily. And finally, we have multiple ways of accessing this system. Part of that can be done through UI, so you can browse the models, and you can click a button to run them in multiple scenarios. But you can also do that through the use of, let's say, Python libraries. Some people prefer to write code in order to consume all of that. And that's how we address different parts of the consumer sections within the company. So all of that really helped us, and that's kind of the canonical, the standard way in which development of ML products is being done across the board at Lyft right now. And I'll hand it over to Jeff to give you the equivalent story for Airbnb.
Cool. All right, thank you very much, Gail. So yeah, I'd love to share with you a little bit about how we've been able to scale AI at Airbnb, and we'll start with talking about the platform. Airbnb is a global travel community, and we enable magical trips, including where you stay, the things you do, and the people that you meet. And when I joined Airbnb 3.5 years ago, we had several. We had maybe a couple dozen use cases for machine learning back then, and 3 primary ones, which included search ranking, basically the ordering of different listings as you do a search, smart pricing, which was around recommendations for how hosts should price their particular listing, given a particular time to booking and other demand signals. And then we had models centered around trust and fraud. So basically, we did some risk scoring where, based on a particular booking and different signals that come in to the model, we try to detect whether it's a bad actor, whether it's a valid guest or host. And very similar to Lyft, teams were reinventing the wheel in terms of building all of the surrounding infrastructure required to train and to score models. And that became problematic when we were thinking about how do we scale out machine learning across our platform. Many different other types of machine learning applications that we were looking to do, including paid growth and lifetime value models, ranking for different types of businesses, photo quality, and other types of models. So the observation that we came across from working with different teams across the company, and the team I'm on is data platform, and we build the machine learning infrastructure in addition to all the other data tooling and analytics that empower users to make decisions with data. There's this concept like intrinsic versus incidental complexity. Intrinsic complexity are the types of complexities that are involved, which should be a part of the process for designing a model. So that requires understanding the specific business domain that you're working in, picking the model and the features, and then being able to fine tune. The challenges that we ran across were incidental complexities, and this is the type of complexity that should not be part of the workflow. And so that included integrating with our warehouse, being able to scale up to multiple machines and do distributed training and serving. One really big challenge that people across the company ran into was being able to train models locally or to prototype versus actually productionalizing a model. And also then being able to do training versus inference. Managing models and versioning and running A/B tests on different types of model versions was also a challenge, in addition to just being able to iterate quickly. So at the time, on average, we found that it took 12 to 14 weeks to build a model. And even when you did build it, the models were really fragile and brittle, and the whole iteration process was very slow. So this was our version of how we saw the machine learning lifecycle. And it starts with being able to first prototype your model. We had a Jupyter notebook framework called Red Spot, which enables people to work in the notebook environment. Then it's about productionalizing a model and the lifecycle management of managing a model. And then when it comes to actually productionalizing your model, we had things around online scoring as well as offline training, offline scoring as well. And then being able to manage your data effectively. And then this translates over into our overall platform, which you see here. All right. So now I'll pass it back over to Gail to talk about some recommendations for how other companies should think about it.
So the question is, of course, okay, I'm a different company than Lyft and Airbnb. What should I do? I want to get started, or I have already started working on some projects and I want to scale my operation. So the real answer is that there's no one size fits all in here, and we think that especially right now with the proliferation of services in all levels, it's very important to take a closer look at what you want to achieve and what's the best way for you to achieve that internally. There are services by all major cloud providers right now, for example, for image classification and natural language processing. And maybe what you need is just to use this high-level service to pipe your data into it and then get back the prediction. Maybe you want to go a step further and use one of the platforms that are available either commercially or in the open source world to do specific tasks. For example, hyperparameter optimization or notebook management or big out-of-memory executions. There are commercial applications to each one of these. If you want to go all in like ours and develop the platform, it's important to understand the evolution that companies like Airbnb and Lyft had in order to get there. So we thought about a framework that had 5 steps in it, where in the beginning, people might work on specific data science projects, maybe even on their laptops, and there's no real collaboration. There's a lot of siloing. In the second step, they try to seek additional resources. They run out of memory. They need something different. And then they want to switch from working on their laptops to working on the cloud in an environment that would allow them to get access maybe to GPUs or to big memory machines or to anything else that they would need. The third step after that is to look at data, how data is organized and how it is consumed. You want to standardize data as much as possible and pipe it at the right time while making it also discoverable for other people so that they wouldn't need to recreate features from existing data lakes. The next step after that is to consider using some tools for pipeline management. In reality, in machine learning, there's a repeated set of actions that we need to go through in order to get the final product, whether it's for training or for inferencing. We need a system to represent that, and it has to be consistent and connected to all of the systems that we had before with respect to compute, feature generation, and the actual models and algorithms that we use. And finally, after we've graduated through all of these steps, then we need to consider how to simplify the work, how to make it easy, how to democratize it, and how to allow different people within the organization, maybe not necessarily the data scientists that have the PhDs in our org, being able to use these tools at a massive scale and still benefit from all of these goodies that we've presented before. So think about it, think where you stand on this spectrum, what you want to achieve, and don't forget what we mentioned in the beginning, which is the culture of the org, as well as training of people internally, getting a lot of people up to speed, can be equally important to these software components we're talking about. So I'll hand it over to Jeff with respect to a very critical answer, which is when to build, when to buy.
Yeah.
Okay.
Thanks a lot, Gil. And I think this is a really interesting question for all organizations that use data heavily and that are thinking about getting more into ML and AI, which is if you're thinking about really investing in machine learning, you have to think about where along the spectrum in terms of to place your investment and whether to invest in a machine learning platform or to actually use like a commercial or other open source offering. And for companies, it's always like a point in time decision from where you want to actually begin scaling your platform and building out the use cases versus what's actually available in the community. So back when we started really investing in machine learning about 3 years ago, there weren't a lot of great third-party solutions at the time. This was before SageMaker and projects like Kubeflow were around. And so we decided to really invest in a platform. We had the engineering talent and the level of investment needed to try to make it successful. We also wanted to have the ability to highly customize our models. We had a very large team of data scientists and engineers who were hungry to try to apply machine learning to our different applications. And so for us, it really made sense to invest in the platform. And I think, a very similar case at Lyft, we had discussions along the way about, this makes sense at this point in time. Now, fast forwarding to today, where you do have the availability of these platforms, it becomes a much harder decision. And so as Airbnb's CTO, Vanya, spoke yesterday, there are good solutions that are available externally. And you have to weigh that versus the availability of talent internally and how much you want to really customize. Anything you wanted to add to that, Gail?
No, I agree with all of that. Basically, Lyft and Airbnb, I think, took a very similar journey. And because we're tech companies, because we have a lot of data, I think our challenges are also very similar. What I'm saying is that for your own companies, just take that with a pinch of salt. It doesn't mean necessarily that what worked for us would work for you. So with that, we wanted to open it up really for questions.
Actually, maybe I will cover one other point, which is one other aspect that we thought about beyond just machine learning platforms is also how do we enable the rest of the business with machine learning at the next level? And so across the top is our core businesses, Homes, Experience, Lux, China, and the Airbnb platform. And then we had Big Head, which is our machine learning infrastructure. The next step that we took was to really develop an applied machine learning team. And the charter was really to help democratize AI across the company. And the things that they participated in, for instance, we helped with developing an internal system for doing labeling. And so there are externally available services for doing labeling, but oftentimes data is sensitive and you don't want to release that data externally. So we and some other peers have internal labeling teams that will label data internally. We'll actually hire and contract people, but we also have a tooling to enable that. The other thing is building machine learning models that are foundational to the business that many teams would use. And so one of the first applications of this was building a listing image classifier, which would go through our full set of images and be able to identify what type of room it is. And then models like that are universally useful across the business.
Okay.
So with that, we'd love to take any questions from the audience, and thank you for listening.
Yeah.
Hi, thanks guys. Just a quick question on how you manage individual product teams when they use this infrastructure, from not deviating from what you have in there to build fringe cases. I'm sure the platforms cover a lot, but not all the edge cases. So how do you manage them from using what they have, but still having the autonomy to solve the problems?
Sure, I can give my perspective, and Gail can add on. So doing internal product development work and collaborating across different teams, it's always tricky because different teams have different outcomes that they're trying to drive. And for us, it's to provide leverage to the organization, and for them, it's to launch a specific product offering. What we try to do is to really focus on collaboration. And so oftentimes what we'll do is we'll look for embedding of engineers from their team onto our team. Because our team will have the expertise, but their engineers can add resourcing to us as well as to help accelerate progress and increase collaboration. In some cases, embedding engineers across teams isn't very efficient, and sometimes what they'll instead do is to build the feature in isolation off a fork of our project. But then when they prove out the value and that it's something that's universally helpful for the organization, then try to reintegrate it with the main platform.
Yeah, so it's pretty much the same for us. One thing I would add is that whenever we identify a potential for somebody else to build something that could be generic and could be an ML platform component, we try to set joint objectives with them so that whether we work together or not, at least we would have a definition of the end state and that it would be as generically applicable as possible.
So you guys mentioned that you all started early and the infrastructure, it made sense for you to build the infrastructure yourself. And obviously sounds like both of you have very mature ML infrastructures at your companies, so you kind of know what they evolve into. So now that you know the world that you can reach and where platforms like SageMaker and all of them stand right now, if you had to make that decision today, knowing what your ML platforms would evolve into, do you think these infrastructures as they stand can keep up with your needs, or would you have built it in-house even today if you were starting over?
Good question.
Yeah, no, it's a really good question. Justin from Google Cloud sits in here. We talked with him right before this. He owns a really cool product called Kubeflow, which could be a candidate to replace some of the things that we have talked about in here. The real answer is that, at least from my perspective, I'm not sure. Because even though the functionality of these tools covers what we had talked about in here, in a big enterprise settings, there's a lot of other considerations that had to do with data governance, identity, access management, logging, monitoring. And so there's a lot of baggage that you need to kind of attune to in order to build these things. And sometimes the complexity is really in these small things, not necessarily in the high-level functionality of the system. So I don't know, but we definitely see a couple of projects as candidates, Kubeflow being one of them.
Yeah, I would say very similarly for Airbnb. It's difficult. It would be a more difficult decision for sure. I think one thing I would know is that we would probably integrate more of other open source or link up with other commercial offerings, but maybe we pick and choose which components or which parts of the machine learning lifecycle that we want to invest in. So yeah, I think it's exciting that the amount of progress that's been made in this particular area to help to democratize machine learning to everyone. So great.
Yeah.
Well, thank you very much for coming and coming to the session. And yeah, we're happy to answer questions afterwards for a little bit.
Thanks.